Imagine a time when the sun burned dim and the young solar system was chaos. Dust storms, fire, worlds colliding. One collision changed everything. A Mars-sized planet, Theia, slammed into the young Earth, shattering both worlds in an instant. From that unimaginable violence came balance, a new Earth, and the moon. This silent companion would steady our planet, tame our tides, and perhaps even make life possible. But here's the deeper truth. The moon is not separate from us. Its atoms, born of that ancient collision, are the same atoms that became Earth, and eventually us. All is one.
So let's journey back to that turbulent beginning, the dawn of Earth and the moon.
We've got some fascinating material lined up for this deep dive. Excerpts from scientific papers, even a few mind-bending theories. But don't worry, we're here to break it all down.
We'll start by exploring how planets like Earth actually form. Then we'll dive into the giant impact hypothesis, the idea that a massive collision gave birth to the moon. And finally, we'll look at how our lunar companion helps make Earth habitable.
Wow. It's incredible to think that without the moon, life as we know it might not even exist.
Exactly. Earth and the moon may seem like separate entities, but their stories are deeply connected. And by tracing that relationship, we start to understand just how interwoven everything in the universe really is. So, how do planets actually form?
Picture a vast cloud of gas and dust swirling through space in the early solar system. Over millions of years, tiny particles within that cloud start colliding and sticking together.
Like cosmic dust bunnies?
Right. And as those clumps grow larger, gravity takes over, pulling in even more material. It's kind of like rolling a snowball downhill. It just keeps gathering mass as it goes.
So the Earth we're standing on today is really the result of billions of years of these cosmic dust bunnies clumping together?
That's right. The process is called planetary accretion, and it's how the building blocks of the solar system came to be.
Incredible. But I'm guessing the moon didn't form the same way?
Not even close. The moon's origin story is far more dramatic. The leading theory is called the giant impact hypothesis. It suggests that in Earth's early days, a Mars-sized object named Theia collided with our planet.
A Mars-sized object slamming into Earth? That's mind-blowing.
It really is. The impact was unimaginably powerful. It didn't just scar the Earth, it changed it forever.
You know, sometimes I wonder what it would have looked like if anything could have seen it. A young Earth glowing with molten fire, and then this rogue planet, Theia, streaking through the void.
It sounds like the stuff of ancient myth. Two celestial siblings, drawn together not by choice, but by fate. One sacrificed, the other transformed.
A collision so powerful it tore a world apart. And yet from that chaos, something new was born. It's almost poetic. As if the moon is Theia's ghost, forever circling the Earth.
Or a child of both worlds. Not Earth, not Theia, but a new being, cradled by gravity, forged in fire, and destined to become a guardian of life.
And maybe that's the deeper truth. We don't just live on Earth, we live in the aftermath of that ancient union. We are the children of that impact too. So what happened after the collision?
The force of the impact blasted a huge amount of material from both Earth and Theia into orbit. Over time, that cloud of molten debris, caught in Earth's gravity, began to clump together. Slowly, it coalesced into what we now call the moon.
So the moon was literally born from this catastrophic collision. That's an origin story for the ages.
It really is.
So not just Earth's child, but Earth's twin, born in the same fire, but still, something changed. The moon isn't just a clone of Earth. It's different.
Right. For one thing, it's incredibly dry. That tells us something important about what happened in the aftermath. How volatile elements behaved during this violent birth.
That makes sense. But if the moon formed from Earth, why is it so different in some ways? Like, why is it so dry?
That's one of the big mysteries. The moon is depleted in volatile elements, things like water, carbon, and nitrogen, especially when compared to Earth.
Volatile elements? What does that mean exactly?
They're substances with relatively low boiling points, things that easily become gas or vapor. Think of water turning to steam, or carbon dioxide bubbling out of a soda.
So when we say the moon is depleted in volatiles, it means it's missing many of the elements that make Earth so vibrant and habitable.
Exactly. And scientists have a few theories to explain that. One idea is that the material that formed the moon was already low in volatiles. Another is that the heat from the impact was so intense, it vaporized these elements and sent them drifting off into space. A third theory? The moon might have slowly lost them over billions of years.
So it could have started dry, had a fiery purge, or just leaked over time? Or maybe all three?
That's right. But here's the fascinating twist. Even with all those differences, the moon is absolutely vital to life on Earth.
Oh, I've heard about that. It has to do with the moon's gravity, right?
It does, yes. The moon's gravity helps stabilize Earth's axial tilt, the angle at which our planet spins. Without the moon, that tilt could wobble wildly over time, triggering extreme climate shifts that would make life much harder to sustain.
So the moon is like a cosmic gyroscope?
That's a perfect analogy.
It keeps Earth steady.
Yes, and that stability is key. It helps maintain a relatively consistent climate, which is one of the reasons life was able to develop and thrive here.
I'm really starting to see how that all-is-one idea fits. Earth and moon aren't just neighbors, they're partners in a cosmic dance.
Exactly. And there's more. The moon's gravitational pull also creates tides, which are essential for moving ocean water, circulating nutrients, and possibly even helping life get started in the first place.
I never realized how crucial the moon is, not just to Earth's motion, but to life itself. We really do owe it more than we think. The moon is so important.
And it's not just a companion, it's also a kind of time capsule. Its surface preserves ancient features, untouched by weather or tectonics, offering clues about what the early solar system was really like. And it holds one of the strangest mysteries in planetary science, something called the isotopic crisis.
The isotopic crisis? Now you've got me intrigued.
You should be. Here's the deal. One of the main goals of the Apollo missions was to bring back lunar rocks. When scientists analyzed those samples, they discovered something totally unexpected. The isotopic compositions of certain elements in the moon and Earth were nearly identical.
Wait, what do you mean by isotopic compositions?
Great question. Think of atoms like tiny building blocks. Isotopes are versions of the same block, made of the same stuff, but with a small difference in weight, usually because of an extra neutron. For example, carbon-12 and carbon-13 are both carbon, but carbon-13 is just a little heavier.
So by comparing isotopes, scientists can trace where stuff came from, like atomic fingerprints?
Correct. And here's why it's a problem. If the moon formed from a collision with another planet-like body, Theia, you'd expect its isotopic fingerprints to be different from Earth's. But they're not. They're almost indistinguishable.
That's wild. So either Theia was nearly identical to Earth, or something happened that completely mixed the two?
Precisely. And that's the puzzle scientists have been wrestling with for decades.
So how do scientists explain that uncanny isotopic similarity?
Well, one idea is that Theia wasn't some distant wanderer from another part of the solar system, but formed close to Earth, meaning it had a similar composition to begin with.
Or maybe the impact itself, like a cosmic billiard shot, sideswiped the Earth and mixed the materials more evenly?
Maybe. But there's an even more mind-bending idea. The synestia hypothesis.
Synestia? That sounds wild.
It is. This structure, called a synestia, was like a cosmic blender. It thoroughly mixed the material from both bodies before gradually cooling and condensing into what became the Earth and the Moon.
That's incredible. It explains the isotopic match and the Moon's lack of volatile elements in one go.
Exactly. And we can actually see what this might have looked like. Let's bring up a recent simulation from NASA.
Using one of the world's most powerful supercomputers, NASA created this high-resolution simulation of a synestia, a short-lived planetary structure born from the collision between Earth and Theia. It reveals a moment when Earth wasn't a planet as we know it, but a swirling, incandescent storm of vaporized rock.
For a brief time, Earth wasn't a planet with a moon. It was a spinning, chaotic mass, hot, unstable, and alien.
And the moon formed within that?
That's the idea. Not from a distant ring of debris, but inside this structure where the materials of both worlds mingled. As the synestia cooled, the Earth reformed at the center, and the moon condensed from the outer vapor.
So the moon wasn't just born from Earth's debris. It was shaped in a crucible that blended two worlds into one.
It seems so. It's a vision of planetary birth that's more dynamic, more chaotic, and ultimately more unified.
The more I hear, the more I realize. The moon isn't just a companion in the sky, it's like an archive of deep time.
Spot on. Its surface is virtually unchanged for billions of years. No atmosphere, no weather, no tectonic movement. Just a preserved record of the early solar system.
So by studying the moon, we're not just learning about it, we're unlocking pieces of our own past.
That's right. The moon is like a key, helping us understand the conditions that shaped Earth, and by extension, life itself.
It's humbling to think about. This little gray orb we see in the night sky is part of a story that goes all the way back to the beginning.
It really is. And that's the beauty of science. Every answer opens up new questions. There's always more to explore, more to discover, more to wonder about.
Next time I look up at the moon, I don't think I'll ever see it the same way again.
We've already talked about how the moon stabilizes Earth's axial tilt and creates tides, both crucial for life. But there's another angle that's even more fascinating.
What's that?
Some scientists believe the tides may have played a role in the origin of life itself.
Really? How does that work?
Tides create constantly shifting environments where land and sea meet. Places like tidal pools that fill and drain with water. That ebb and flow could have created the perfect conditions for early life to emerge.
So those little pools, wet, dry, wet again, might have been nature's first laboratory.
I like that. And there's more. The moon might also influence something even more critical, Earth's magnetic field.
I've heard about that. Doesn't the magnetic field protect us from radiation?
Yes, it acts like a shield, deflecting harmful solar and cosmic radiation. Some researchers believe the moon's gravitational influence may help stabilize that field over long timescales, adding yet another layer to its protective role.
So the moon isn't just guiding our tides, it's helping keep the planet safe.
Right. It's incredible to think this relationship has lasted for billions of years. A quiet cosmic partnership that made life possible.
Studying the moon also teaches us a lot about the early Earth.
That makes sense. They formed together, right?
Perfect sense. The moon acts like a cosmic archive, preserving conditions from a time when the solar system was young.
So by examining it, we uncover secrets about the materials, collisions, and processes that shaped our own planet.
Yes. The more we learn about the moon, the more we realize just how rare and fragile Earth's conditions really are.
It makes you wonder, are there other planets out there with moon-like companions? Systems where life might also have a chance?
It's possible. While we haven't found solid evidence of life beyond Earth yet, the universe is vast and full of untold possibilities.
And who knows what we might discover next? Every new planet, every new moon we find could help us better understand the delicate balance that makes life possible here.
That would be incredible.
It would. It's humbling and inspiring. We've come so far in understanding this cosmic partnership between Earth and Moon, and yet there's still so much more to explore.
I'm really curious. What's next for lunar exploration?
One of the most exciting frontiers is the search for water. For years, we thought the Moon was bone dry, but recent discoveries suggest there may be water ice trapped in permanently shadowed craters at the lunar poles.
That could be a game changer, right?
Absolutely. Water isn't just for drinking, It can be split into hydrogen for rocket fuel and oxygen to breathe. It opens the door to sustainable lunar missions and maybe even a permanent base on the moon.
Imagine that, living and working on the moon as a stepping stone to the stars.
And all of it, every future launch, every footprint, traces back to those ancient collisions that shaped Earth and Moon in the first place.
This journey has been amazing. I feel like I understand our place in the cosmos a little better.
Me too. And this is just the beginning. There's so much more to uncover. So many mysteries still waiting for us.
So before we close, let's take a moment. What stands out most from our exploration?
For me, it's the scale, the sheer drama of it all. A young planet forming, a world colliding, debris becoming a moon, and somehow, life arising from it.
Out of chaos, balance, out of destruction, life. It's a beautiful paradox.
It really is. Earth and Moon aren't just orbiting partners. They're co-authors of the same cosmic story.
Exactly. And by reading that story, through rock samples, through tides, through the tilt of our axis, we're also reading ourselves.
The moon reminds us that we're part of something bigger. Part of a dance that's been going on for billions of years.
A dance born from collision, from a moment when the sky itself came crashing down.
And yet, from that cosmic violence came harmony, balance, life.
In our mythology, maybe that's our first lesson. Even destruction can be the beginning of something sacred.
And now, that ancient dance is calling us back. With NASA's Artemis program and new missions from China and India, humanity is preparing to return to the moon, to walk its surface again and dream beyond it.
And maybe, just maybe, looking up tonight will feel a little different.
It should, because the moon isn't just a light in the sky. It's a mirror, a memory, a message.
And a reminder, all is one.
Out of chaos came balance. Out of destruction came life. The moon isn't just a distant companion, it's a witness, a stabilizing force, a quiet partner in the grand experiment of existence. Its atoms and ours were born of the same collision. In that sense, we are not separate. And maybe that's the deeper story. The universe isn't something we stand outside of. We are part of its unfolding, its memory, its becoming. So next time you look up, remember, the moon is not just out there. It's in here, and we've only begun to trace the threads that connect us. All is one.